I just wanted to go through my design for Electrical Principles 1. Power supply for 80 milliamp 2.2 watt contamination monitor. So this is the design which you have. I just wanted to go through quickly how I tested it. Three millivolts ripple on the output. Output's 24 volts. Let's put a ground in for this. I think it doesn't like, the simulation doesn't like this being put in with the ground. Okay, 89 milliamps, 24 volts. Still 24 volts. Okay, it's being limited now to 160 volts, just dropped slightly. It's not increasing. Okay. So that's regulation and limiting. So now over voltage. So this will read any current going through the SCR here. This is the circuit here. So I've got a 33 volt Zener, and that breaks down a bit of voltage across here and to the gate. And I am putting the extra voltage in from a separate source here. So I'll start with 33 volts. It's okay, it's not been triggered. 34. 35. 36 is the spec, so it should go at 36. Okay, 37. there it goes. So it should blow. Should blow. So that's reading current running through. Yeah, they've blown. So if you get 40 volts up here, 39, opens the gate, dumps that through here. Okay, I think that's it. Cheers. Okay, here's my finished power supply. Transformer. The rectifier is just coming out of the transformer on a small board here. Half amp fuse. Smoothing capacitor. And everything else here. I don't have the overvoltage circuit. I don't have the right components to finish that. So this is only testing regulation and current limiting and ripple. Also, I've got an added LED on here, which I don't have in the circuit, but this I needed it because when working on it, I needed to know it was powered up. Okay. First test voltage. Voltage coming out of the transformer. 35.3. Oh, it's under load at the moment. Just take it out that way. $37. I think I've got 39 in the multi-tin model. So 25, which is a volt higher than I was expecting, but I don't have the resistors and the time at the moment to adjust that. But it proves that it is regulating the voltage, well, dropping it down at least. And I'll just prove this voltage going in is 230 volts, 227. Okay. So now I will test the ripple and load. So this is a 470 ohm resistor. It draws about 50 milliamps through the circuit. And I'm going to clamp the probe onto the positive side of the last capacitor just before the output, and I'm earthing it on the negative side. I'll just turn it on. Okay, I don't know if you can see the scope from there. I'll just move you in. Okay, I've got it to 5 millivolts on each square range. It's on AC. Just check that. Yeah, it's on AC. I have a trigger line I can move up and down, which goes off when it hits the peak. So as I bring this down, this will switch to triggered, and down here gives me the trigger voltage. So as I come down, the light will flick when I hit the peak there, and that's reading 9.4 millivolts on the output. So I'll just do that again. There, 9.4 again. So not a bad output. Okay, so now I'll do load regulation. My previous test, this is where exciting stuff tends to happen. So hopefully not during this test. I'll just check I've got this set up correctly. We'll turn this on now. We should get a reading of about 50 milliamps. Yep. So I've got this set up on a 10 amp resistance on here. Well, you can handle up to 10 amps. So now I'm just going to short straight across, which should limit it to 160 milliamps. Fingers crossed. Yes. And the LED hasn't lit up because it's probably about just a few volts going through. So I'm just going to turn that off. Oops. So I think that's everything. Okay, final test is to test that it can actually run the device that it was designed for. So I just wired it in. I've also put the multimeter in to read the current. So that's what's happening here. I've just wired it into the cable. Cable's here, multimeter's here. So this is an oil contamination monitor. 2.2 watts at 80 milliamps is the maximum it needs, what it should draw. So we'll just fire it up now. 50 milliamps. And that's working fine. Okay, so that's everything. Cheers.